discover another rule. Okay, we know that 5 divided by 5, it is 1, right? It is 1. But we can write it as 5 to the first power over 5 to the first power. According to the rule over here, this rule, the quotient rule over here, when they divide, they have the same base. We keep the base, we subtract exponent. So 1 subtracting 1 over here, 1 subtract 1, which is this one over here. This is going to be 5 to the what power over here at the end?
0?
5 to the 0 power, yes. Now, this is 5 to the 0 power, which is equal to 1. You see, we just discovered that 5 to the 0 power is 1. Okay, notice the 0 power here just means that the exponent over here subtract out. Okay, that means they are the same over here. So dividing over here, you get 1. Okay. Similarly, suppose we have a to the second power and over a to the second power. Well, for non-zero a. So dividing this, we get 1. Okay. Now using that quotient rule, using this quotient rule here, that is equal to a to the, we subtract exponent, right? 2 subtracting 2. So this will be a to the
0
power. And now you discover a to the 0 power, it is equal to 1. Okay, right? So this is called the 0 exponent rule. Okay, for any non-zero a, okay, let me write it down. This is for non-zero a. You cannot divide by 0. That's why we have to say non-zero a. Okay, so for any non-zero a to the 0 power, it is equal to 1. Okay, think about this exponent here. Think about this example, these two examples. Okay. Okay. Now we're going to assume all variables. Over here are not 0. Okay. So 5 to the 0 power is equal to 1.
1.
1. Good. Okay. What about this? 5x to the 0 power.
1.
1. Yes. 1. Good. Okay. This one here, 5 times x to the 0 power. This exponent only apply to this x over here. There's no parenthesis around the 5x. So this exponent only apply to x. This exponent has no control over this 5.
Okay.
Okay, so this part here, it is a 1. 1 times 5 over here, it is a 5. The next one over here. Remember, this exponent only apply to this base inside the parenthesis, right? Okay. So what does that equal to?
-1.
-1. Because this part here, it is a 1, and then this negative sign in front. So it is -1. Okay. All right, so what about the next one over here?
5b.
IB, right? Because this exponent only apply to this a. That's the case for this exponent. So a to the 0 power, it is a 1. So 5 times 1 times b, which is 5b. Okay. Okay, good job. You guys just discovered the 0 exponent rule. Another student has they have difficulty remember this, but I hope you remember. Okay. Okay. And I hope that you understand why y is equal to 1 also. Okay. Okay, now we'll try to discover another rule. Okay. A to the second power divided by a to the fifth power. So remember the quotient rule. So we keep the base and we subtract exponent. So 2 subtracting the 5, which is -3, right? So it is a to the -3rd exponent. Now I can also do it another way, right? I can write this a squared as a times a to the 5th as a times itself 5 times. Now this cancel out, okay? Leaving you with 3 factors of a in the denominator. So up here we have a 1. Down here we have a to the 3rd power. So it's 1 over a to the 3rd power. So this is the same expression that we start with. If I do it this way, I get a to the -3rd power. If I do it this way, I get 1 over a to the 3rd power. So they are actually the same. They're the same. So you see this negative exponent over here, actually indicating that you are taking the reciprocal of this a to the positive 3rd exponent. Okay, so the negative exponent indicating you're actually taking reciprocal. Okay, So you see this negative exponent here, then you take a reciprocal, you put 1 over, and then you change this exponent here to positive. So positive 3. So you put a to the positive 3, positive third exponent down here. Okay, so that indicates you're taking reciprocal. Okay, now in general, okay, so a to the negative n exponent, if n here is a positive number, okay, then you think about it's a reciprocal, it is 1 over and a to the positive n exponent. Okay, now let's try this one. 4 to the negative third exponent, what would this be? We know it is reciprocal, right? So it is 1 over what?
1 over 4.
4 to the
Third.
third, right? 4 to the third exponent, right?
Mhm.
Okay, 4 to the third is 4 times itself 3 times. So what would that be?
4.
64, right? So it is 1 over 64. Okay. Okay, the second one. Negative 2 to the negative fifth power. Now we have a negative number raised to the negative exponent. But don't worry. Okay, so we do it step by step. So we first take care of this negative exponent here first. Okay. So that indicates we're taking reciprocal. So how should I rewrite this?
1
1
over
over, yeah, 1 over what?
negative 2 to the
Negative 2 to the fifth power. Yes. So negative 2, and then put the positive exponent 5 right here, right? So negative 2 to the fifth power. So put it down here, okay? And negative 2 times itself 5 times, it is negative 32, okay? So the result here, it is negative 1 over 32. Let's try the next one. So over here, this exponent, the negative exponent, the base over here is what?
M.
Only the m, right? Because there's no parenthesis around the 7m, okay? So only this m. So the 7 over here is going to stay. So it's going to stay here. Now, this negative exponent here indicates you're taking reciprocal. So we will write this as 1 over
M to the 8th power.
and 7 is the same as 7 over 1. So you're going to multiply with this numerator on top. So we
So
can
7
7 on top, m to the 8 in the
out.
denominator.
Okay.
So in the future, you see this 7 here, then it's going to stay on top in the numerator. And then this m to the 8 is going to go to the denominator here. So this is multiplication. So what about this one here? What's the base for this negative exponent here? Here is the base. So the negative side over here is going to stay. Okay, so you have this negative side here going to stay. Okay, so this n to the negative 4 power, we write this with positive exponent. What would that be? 1 over n to the 4 power. Okay, good job. Okay. Okay, what about this next one? This one over here, remember they're side by side. They have the same base, okay, kind of like coworker, okay, side by side. So we will keep the base and add the exponent. Okay, so keep the base x. So add the two exponent,
negative 2.
negative 2, negative second, right? So x and negative second. So we normally like to leave the final answer here with positive exponent. So let's rewrite this with positive exponent. So what would this? Good job. 1 over x to the power 2. Good job. Okay. Okay. Now the next one over here. X to the negative third exponent and then parentheses raised to the negative second exponent. It looks like it is the power of a power, right? So what do we do with the power over here? So the what power?
6.
Positive 6, right? That will come up quickly, right? That's easier this way. Negative 3 times negative 6. This is positive 6. Okay. Okay, you guys did a good job. Okay. Wow, you can learn a lot today. Okay. Right. So the next one over here. This time we have a negative exponent, but it is in the denominator down here. If I do it this way, okay, so 1, remember that's the division side. So it's 1 dividing by a to the negative second power. Now, a to the negative second power, it is 1 over a squared. Now, dividing by this is the same as multiplied by its reciprocal. The reciprocal of this is just a squared, so it is equal to a squared. So in the future, we can go straight from this to this, okay? 1 over a to the negative second power. Then you take away the negative sign in the exponent, you flip this a squared up. Okay, like this. So change negative exponent here to positive and you flip that up. Okay. Okay, what about this one over here? 1 over c to the negative 10 power. What is it equal to?
So it will
To the
be
10th
c
power.
to the 10th power.
10 power. You got it. Good job. Okay, what about this one here?
Three
Okay.
to the fourth power over 2 to the third power.
You got it. Okay. Now over here, 2 to the negative third power. The negative exponent here means you take a reciprocal. So you have this reciprocal. So you take this exponent to be positive, and then 2 to the third power will go down here. Okay. So 2 to the third power will go down here. Now this is also reciprocal. The negative exponent means you take a reciprocal. So 3 to the 4th power, and you're going to flip it up over here. Okay. Like this. You got it. So it's 81 over 8. Good job. Okay. And then I summarize this. Okay. So I summarize everything here. Okay. Today. So for non-zero a over here, a to the 0 power, it is 1, right? You get to discover that. Okay. A to the negative m power, it is 1 over a to the m power. So you change this exponent here, take away the negative sign in the exponent, and you flip this a to the n down to the denominator. Okay. Now over here, you take away this negative sign in the exponent, you flip this a to the n up. Okay, because it indicates taking reciprocal negative exponent. Okay. And then for this one over here, you take away this negative sign exponent, you flip this a to the m down here, take away the negative sign exponent, flip b to the n up here. Okay. Now the last one over here, okay. This is negative m power, okay. So negative exponent means you're taking reciprocal. So let's take the reciprocal of the base over here. The reciprocal of this base over here, it is b over a, okay. And then after you take the reciprocal, you change this negative exponent to positive. So you change the exponent from negative n to n. Okay, so reciprocal of this. Are you guys good?